Those who are live here, remember to switch off all your mobile devices on silent mode. And do remember Q&A will be at the end of every session. Thank you. So may I invite the first speaker, Mr. Joseph Ahmad, who will be presenting or sharing on a research topic he has studied, enhancing emergency message dissemination efficiency among vehicles for urban, vehicular, and ad hoc networks. So, what is your slide? Which one? Not here. Okay, should be this one. Yeah. This one again. Okay. Problem? Okay.
Assalamu alaikum. Our distinguished guests, ladies and gentlemen, warm welcome. First, I want to thank USM CS Journal Club, represented by Professor Manment and Professor Jibrail, for organizing this event and their effort. Also, I want to thank my advisor, supervisor, and mentor, Dr. Suzy Arianti, for her trust and election me to participate in this event. All the attendees, thank you for your attendance. I'm Yusuf Ahmad, postgraduate student, Intelligent Computer Technologies, CS Department, USM. The recent decades, there was a great revolution and evolution of the devices connected to networks and internet. And a huge challenge appeared because of the sharply increase of the vehicles and roads. So this flight of the need to study the intelligent communication systems, ITS systems, and the vehicular networks to increase and save people's lives, to increase the safety, avoid the road jams, traffic jams, and facilitate the transportation in general. Our study focuses on enhancing the messages transmission in vehicular ad hoc networks, especially in the urban regions like cities, villages, and like this. This is the contents that we will walk through in this presentation. I will not focus too much in this slide, but a brief description. First, we will talk about the statistics and numbers that guide us to work in this paper. Explain some technologies improvements that happened in the last decades, especially in the transportation systems. We will talk about the technologies that we used, the tools that have been used to achieve this paper. Also, we will talk about the way we worked on this subject, how we collected data, how we did our simulation, our calculations, and go out to the results that we find, and also if there is any future devices to complete these studies or to work on studies depending on our study. Before we go for this statistics about the accidents and traffic jams, and also if you go to the mobility connected devices, we'll talk a little bit about the population of worldwide numbers. No one had predicted that population will increase from 1900 to from 1.5 billion people to 6 billion in 2000, and in just 2 decades the number increased of more 2 billion people. This led and resulted of increasing the number of vehicles in the roads. In a study in 1996, the number of vehicles in roads, especially cars, was around 670 million car, and in 1920 it was around 1.5 billion cars. This sharp increase of vehicles resulted in sharp increase in accidents, traffic jams, and problems in the road. If you see, as we are students in Malaysia, the transport minister announced that in the past 2 years only, there was 1,500 accidents in just 2 years. In 222, 545 plus accidents reported and around 6,000 deaths. That means we are talking about around 20 dies every day, 20 deaths, 20 losing of lives every day because of accidents in the roads. This is a huge number. This is a huge loss of not of people's lives, of economic effect, especially when we are talking about this huge number of accidents. And if you see the graph here, you will see that there is a sharp increase of accidents from 2010 to 2019. We can forget about 2020 because of the COVID, but this is a huge increase of number of accidents in the past decade, only in 10 years. If you see that there is a report from the nation in 2017 talks about that this happens in ambulances, in emergency vehicles, and the number is 20% of the transported people of the vehicles are dying because of the latency of vehicles, emergency vehicles, and because of the traffic jams. Also, BBC reported that is in America, especially in the west side of America, that 2,500 lives are being lost in US because of the delay of the ambulances. In 1990 to 2009, about 84.8 ambulance crashes were occurred in 1 year. In the past 20 years. This is the emergency vehicles that's supposed to save people's lives. That's our talk about the traffic and the lives that we lose in the traffic. Now we will talk about the improvement in the technologies in the past years. We talked about the population of world that increased incrementally and sharply. Let's talk about the mobile devices and especially about the vehicular devices increase in the past years. Statistics shows that connected devices across all sectors of industries exceeded 8 billion devices in 2020, 8 billion devices. In the mobility sector, we are talking about 1 billion connected devices in 2020. And it's predicted that it will reach about 2 billion devices in 2035. This huge increase will certainly increase the need for improving the communication systems and the intelligent transport systems, which I will talk about in a few seconds. So now we can clear the title of our paper. We are talking about emergency messages that is will help in save lives. These emergency messages, we will work on it to increase its efficiency by decreasing the time to send it, increasing the time to live for it, increasing the distance that it will reach, and of course, by this, we enhance the dissemination of these messages, especially in urban regions, in cities, and in populated places, using VANET networks. There's many concerns applied in the past decades, which is very similar to together, and it leads to our sector of study. In the past decade, we started to hearing of concepts like IoT, Internet of Things, like smart cities, ITS, Intelligent Transport System, VANETs, and many phrases like this. Well, let's a little bit explain about these phrases and define some differences between them. IoT, Internet of Things. We are talking about a collective network for connected devices and technologies to facilitate communications and applications to manage, monitor, and maintain these devices. So we're talking about any device with sensor. Any device can receive or send signal. It could be any device. It could be a mobile. It could be a smartphone. It could be a laptop. It could be a vehicle. It could be a flight, aircraft, drone, even ECG, electrical cardiogram, or the device for monitoring the heart status. It could be the sensors that we put on wild animals. Any device that can send a signal and connect it to the network is a part of Internet of Things. Many researchers says this is, we can talk about this networks if it is connected to the internet, whatever. Smart city, it's a part of the IoT. We are talking about the same concept, but in urban region, in limited region, like a city, a village, or any urban region. ITS, Intelligent Transport System. We are especially talking about the transportation systems, if it is flights, if it is trains and railways, if it is cars, buses, emergency vehicles, only transportation systems. And it is especially talking about the part of vehicular, let's say the ground side of the transportation system. Minute, mobile ad hoc network. We are here a little bit specialized now on the mobile devices, on the flying networks, dynamic networks, not the wired networks, and about the mobile devices. So, minute, I'll be faster, okay. Minute is about mobile ad hoc networks. Ad hoc means, if you got the Latin word for this, that means it's a group or set of technology or people, a group temporary to achieve a specific purpose. One minute talks about three specifications: mobile devices, about VANETs, which is about flight, aircrafts, drones, and VANETs, which we are talking about, it's about vehicular ad hoc networks and specified about the roads and transportation system in the ground. So, what is the problems that guided us to this paper? First problem is, let's imagine a scenario before we start with the problems. Let's say there is an accident happened in front of you, directly in front of you. How to avoid this accident? What time you need to avoid this accident? And what if I already emergent or alarmed before that accident of seconds, or before a distance, meters, or even kilometers? So the first problem is in a road like Gomber Galan Street. The speed in that street is Bukit Galan. The speed in that street is limited to 65 kilometers per hour. That means around 18 meters per second. So the safe distance between car and car, as traffic rules, the 3 seconds rule, is about 55 meters. This safe distance is for, a reflex reaction. I saw the accident. I don't want directly to move from this accident. I need at least 3 seconds. This 3 seconds means 55 meters distance. What if I didn't get the message? What if I was annoyed, but whatever it was? So my message must at least reach hundreds of meters. This is about the distance. And my message must reach me before more than 3 seconds, before a longer time. And it's better if I get the message when I was in another street to change my lane or change my route. And if this message was distributed and lost in milliseconds or seconds, what's the benefit of this message? And in technologies now, the most communicated data is about content. It's about internet browsing, or about communicating or streaming or phone calls or like this. So there will be a huge data transmitted through the internet. What will ensure that my message will reach and will stay for a long time? That's why we have to do some changes. Our first objectives, as we said, time is very important. Time of receiving the message, response to the message, and the time to keep this message. So our first objective is to ensure widespread dissemination of emergency and warning information for maximum number of vehicles in a timely manner. This is the first thing, and this information must be retained for an extended duration to enable drivers to response appropriately. Our second objectives is to keep this message for a very long time. So emergency messages must stay a long retention period to ensure they remain accessible for vehicles for an extended duration, even in a dynamic network conditions. Let's talk about the VANET components or the vacuolar network components. The first component is the part or the sensor, let's say, in the vehicle, which is OBU, on board unit. It's the part fixed in the vehicle, having computing capabilities and communications ability to communicate with other vehicles or other infrastructure like RSU. And RSU is the roadside unit. It's the infrastructure beside the road, like traffic lights, towers, any place, intersections that can I put a device or a tower to collect the data and send the data. This is called RSU. And there is 3 types, or let's say scenarios for communication in such environment. First communication is V2V, vehicle to vehicle communication. Second is infrastructure to vehicle and infrastructure to infrastructure. I will not focus a lot here. Let's talk about our protocol that we are using. In communication, most researchers focusing on the routing protocols. Few studies pointed to the application layer protocols, especially in specific topics like vacuolar networks. And if you can see, there is dozens and maybe hundreds of protocols that are talking from physical layer to transportation layer in communication. So they're all talking about routing and sending the message. Now, in recent years, the demand for protocols that understand the data, understand the information, not only a message carrier. You need a messenger who send the data, understand the data, and tell what is the data, what is the information. This is the difference. That's why we are talking here about an application protocol, like vacuolar information transfer protocol. This protocol is a layer 7 protocol, one of the very rare protocols that talking about this layer or working in this layer. The characteristics of this protocol helped us to do our paper, and it will help to create many applications in the future, geographically aware and intelligent enough to work with modern technologies like artificial intelligence or IoT or data mining or huge databases. These specifications, in addition to that it is working in application layer, that it is location oriented. This protocol understand the coordinations, understand the X, Y, Z coordinations, understand the locations, and can deal with locations like a part of a street, a part of location, or a street, or a route, or a convert, or a U-turn, can understand these things. Also, it's stateless. I like one description of a researcher. He said you can consider VITB as a simple application, not only a protocol. You really see a protocol with 3 layers of communications. VITB peers can work in session layers. That means it can process each message alone, individually, without affecting other messages. Also, this protocol can work with both methods, can push data to around environment or can pull data from the around environment. The flexibility in this protocol, there's many parts that you can work on it to make some modification to help you in your research or to help you in your applications, especially that some flags that you can use, like in my paper, I used it for prioritization and give it the message priority to keep this message or remove it. And one most important specific characteristics of this protocol, and it will help many researchers when they work on security part, especially the privacy of this protocol. This protocol hides the identity of the sender or receiver in the message, so no one can know exactly who's the sender or the receiver in the network. Now, how we work? One time. Okay, I'll go through this instantly. Collecting the data, first part of our methodology. There is 3 parts of collecting data. First part, that we used previous papers from researchers about the statistics in the regions we selected to work on. We went to the road and monitored the traffic in several conditions. We selected a specific area, and we will talk about this area exactly, Jalan Pocket Campbell Street and Penang. And why we selected that? It's a very great sample because it's a small area, less than 5 kilometers, with 5 traffic signals, which can be used for RSUs. And there is a difference in traffic between hours. I mean, in peak hours, there is a huge difference. In holidays, a huge difference. In normal hours, it could be low traffic. So there will be many scenarios that we can be tested in this area. A real area with 5 signals like this. The distance between these traffic signals are already here. What you are waiting on each signal, the time you wait on each signal already tested and monitored. The VITB structure, the protocol that we are using, I will not focus on it because we don't have a lot of time, but the most important is the message layer of the VITB protocol. This layer is very flexible to use. In addition to the message of the message body, there is a lot of header flags that you can use, like caching enabled, or any other additional flags that we used and configured in our simulation for prioritization. Structure of the VITB, I was a little simulation bar that we used. There is 3 major core simulations in our work. The first simulation is to simulate the traffic in the road. So we used a traffic generator called SOMO, not the Japanese wrestlers. It's a simulation of urban mobility simulation. Omnet for traffic simulation. Beans is the umbrella, is the framework that connects the traffic and the network communication under it. To get our sample map, you can't use like Google Maps or something. We used online application that you can access only by putting the link OpenStreetMap on any Explorer, Internet Explorer. You can select any area there. You can export this area. The huge benefit of this online application or web application that it's not giving you only the map. It's give you the characteristics of the roads, the speed of the roads, speed limits, the traffic signs, the walking lanes, the traffic expected on these places. And you can export this data to another software so you can use it, which we used in JOASM Java OpenStreetMap software. It's a Java software that facilitates the editing of the network, so you can deal with it. You can remove some routes to get your sample. You can add some routes. You can modify the specifications of the roads, like the speed limit, like the number of cars. Okay. After that, we use some Python scripts to export and convert this piece of map to XML files that can be used in SOMO traffic simulations. SOMO traffic simulation deals with two core XML files or configuration files and many other additional files. The first file is net file, XML file, and the second file is route file. The net file contains all the streets on the simulation, traffic simulations, which called edges in there, and all the nodes, which is vehicles, cars, and the routes. The routes are, let's say, the roads that the vehicles will select and move in of these edges. Also, for network simulation, we used the main network simulation was ONNET++, and there is additional frameworks and softwares that embedded or connected, integrated with it, like INET, which gives you the ability to deal with protocols. Also, with Beans. Beans is the umbrella that connected the network and the simulation and the traffic simulation. This is the parameters that we used in our simulations. In brief, the results was shocking. We were talking about, if we are talking about 1% enhancement in road safety, we are talking about around 20 lives per day. If you see that in our experiments, there was a huge enhancement, about 30% enhancement in time trip, round time trip, and 20%, 91% in query rates. That means that the signals that received from the nodes, 91% increment enhance if you using high density of nodes and RSUs. For future studies, first thing, we see that the huge impact of enhancing the intelligent transport systems, especially the transmission of messages, in saving lives and in enhancing the road traffic and calming and avoiding the accidents. We see that enabling the VITB for specific characteristics like caching and prioritization, how enhance the decimation of signals, and the most important that working in application layer protocols opens the door for future studies, especially in artificial intelligence and data mining research in the future. Sorry for being rapid and fast in the past slides, but I think I took more than my time. So if there's any question, I'm ready.
Okay, thank you, Mr. Yosef, for the presentation. We now open for Q&A. Any question in the house? Those who have joined online can send their questions to the chat box. So you listen and understood everything. Okay. Dr. DeBras.
Okay.
The question?
A little bit the voice was
He wants to know about the protocol you want
Yeah.
to use.
protocols. Okay. There is two protocols that we used in application layers, which allows us to deal with information, not only data sending or routing. It was VITB protocol, Vehicular Information Transport Protocols. It's very flexible and a huge structured layers of protocols. It's geographic aware. It's location aware, I mean, geographically. It's also can deal with other protocols in lower layers, which we used. I didn't have the time. We used in routing layer or transport layer, AODV protocol to transmit the data and integrate with the VITB protocol in sending the messages. Did I? In which state? Stage. Oh, we already finished. Yes, we are working now on the statistics, especially that I'm increasing the scenarios that I'm working in. Instead of working in the, like, we worked on high density cars and low density cars. We worked on scenarios like 50-meter transmission, 100-meter transmission, 150, 200-meter transmission. Now we are trying to cover the whole street with RSUs to check if it will enhance the solution, especially that we get result like 91% of messages received in only using 5 traffic lights RSUs with 200 diameter only of signal sent. We already finished. We are working in some new scenarios or increase the scenarios to get some good statistics. I'm already learning about SPSS to evaluate and analyze the data that I got. Yep. Yes. Okay. I didn't get enough time to explain everything, but let's say in wireless network, most companies says that the wireless signal can reach 15 meter in closed area and outdoor area 100 meter, and some companies claims that it will reach like 300 meters. So enhancing the signal from the OBU or from the vehicle itself, it will not work. On the other hand, using your mobile in anywhere can get signal and send signal. Why? We are using towers that can send, which in our case will be RSUs. We can reach like in one study like 40 kilometer, cover 40 kilometer distance. So in our study, that's why we focused on RSUs. And we talked about traffic signals. You can increase the density or the distance to kilometers if you want, especially in like Penang. It could be covered by few towers to fully cover the network for the vehicles, for the ITC system. It's not about 200 meter. My test was about 200 meter. My simulations was about 200 meter, because if I increase the sample or the distance, and my sample was only 5 kilometer distance, it will be covered by 3 or 1 RSUs. But if we increased our research and studied Penang City, which has already started to work on it, yeah, it will be visible to increase the RSU's destination and the limitation. Welcome.
Okay. Question? Okay.
Your title will be emergency message. So it's a very important message. So do you have some consider in security, data security transmission?
Data security in our messages wasn't included. Okay, wasn't included in our studies. What we said about emergency messages, that means the messages, important messages to avoid all about accidents and traffic jams and problems in the street. But about the security side, I think hundreds of studies focus on the security side. But the problem was that most of these studies focused on the transmission of data until the transport layer, the fourth layer of transmissions. There is many problems and threats appeared in the past years, especially like ransom virus, which works in the session layer, in the encoding, decoding, and in the encryption, decryption layer, session layer, layer 5. Okay, these viruses cannot be secured on such security studies about the first 4 layers. That's why we talked about VITB layer or VITB protocols. We can understand the information. It can understand that there is or can be done, studies can be done on it about understanding that there is injection in my data, in my information. Like there is encryption or coding in my data. So yeah, it opens study for security side in layer 7 security or application layer.
Okay, thank you so much, Dr. Yosef, for the presentation. You can now return things. So now we move to the second presenter, who is Dr. Banteji. Okay, she is presenting on the topic Edge Computing and Cloud-led Network Architecture for Data Transmission and Distribution. Dr. Tegi, over to you. Is it?
Yeah.
Share in the WebEx.
Should be there now. So, Dr. Van, take it over to you.
Okay, good afternoon to all. Okay, since we have limited time, I'm going to make it short and sweet. So I'm not going to go too technical into my presentation. So if you have any question, you may let me know, then I'll try to answer. Okay, so actually I have some changes in my topic. Okay, it's actually for edge computing and cloud-led network architecture for metaverse network. Okay, I'm sorry for the late changes. Okay, so I'll start with the okay. Okay, I'm very, at the time being, I'm doing research on the metaverse network. Okay, metaverse network is actually not it's actually a very popular topic now among the researchers because it's expected to become a very every industry are going to use metaverse in future. Okay, after they have already experience of having a online kind of meeting, online educations and all that, they felt that metaverse can become the next technology that can be used in every industry. Okay, so that is about the metaverse. Metaverse is actually about representing ourselves virtually into another virtual world. Okay, so I'll go next. Okay, so now as a lecturer, when I teach my students, especially related to the networking studies and all that, okay, I want to explain to them about, okay, this is how the data will be transmitted. This is how the server will be doing things and all that. But when I explain or read through my slides, it was hard for them to actually understand what's going on and so on. Then what I will always do is I'll draw to explain to them, this is how data will be transmitted. This is what router does and so on. But still, it is not actually, some of the students won't be able to have the imaginative world thinking to imagine what's actually happening and so on. Then we found out that metaverse actually, these are the benefits of metaverse in education actually. It gives you an immersed learning experience whereby you can have like you will be at physically at your location, but then you can represent yourself virtually at another virtual network or virtual world. But then everything that you are experiencing will be exactly like how you are experiencing in real time, physically. Okay, so that's one of the advantage of metaverse in education. Then personalized learning, expanded access to education. Like now I'll be sitting in one place, but I'll be able to go to the library through metaverse. I can go to the lab. I can go to so many places just by sitting at one place, and I can experience exactly like how I'm going physically. Then hands-on learning experiences, like what I said. Now, if I want to do develop a network, I have to do it in a simulation. Okay, so that because most of the devices, hardwares and all that are very expensive. So in order to see whether it works or not, to let the student to experience that, normally we'll do in simulation. So, but then hands-on through metaverse, we can enhance that, okay, by having hands-on learning experiences. If you want to know more about the how students actually will experience the metaverse world in education, you can go to the YouTube, but I don't think so we have enough time to go through that. So maybe later if we have extra time. Now problem statements. In future, let's say USM want to adopt a metaverse education system. Okay, these are the most common problems that they are facing nowadays. One is through the research. Okay, one is the cost. In order for us to be in the metaverse world, we have to have lots of VR, lot of devices like VR headsets, augmented reality devices, and so on. All these devices will cost you a lot. Okay, that's one. Then the second one is security. When you are using the VR headsets or all the VR, IoT sensors, all these devices, most of our, we will be transmitting most of our highly confidential data and so on. So when we are transmitting this data, high chances for this data to be hacked by the irresponsible person, like the hackers and all that. Okay, so that is the main concern. Let's say for students, they will be sharing most of the data like fingerprints, their face recognition, maybe the passwords and so on, all the other authentication data that can be easily hacked by the hackers. So now that is the main problem that is happening in the countries that already utilizing metaverse education. Okay. Then we go for the technical part. In order to have the metaverse class, the network must have a very high bandwidth and also must have high powerful computing resources, reliable data storage, and also it has to be scalable for technical. So now what am I going to talk about is about the technical, how to tackle the technical part. So as I say, it's not going to be very technical. I'm going to make it very simple. So research work were done, but they were saying that all the data, like when we are wearing all the VR devices and all that, when we are transmitting the data, we are actually transmitting lots of data. It's not like I'm sending email 1 megabyte, 1 gigabyte of data and so on, but we have lots of data because we will be using a lot of devices. So when we want to have real-time interaction, okay, and if we follow this kind of network, okay, these network suggestions whereby all the data will be uploaded to the cloud computing and the response, the feedback will be given to us through the cloud computing to the device, it will take time. Okay, so some of the issues are the latency, high bandwidth consumption, and security. These kind of problems we can't be acceptable in the metaverse world, because in metaverse world, let's say for example, the Tesla car. Okay, Tesla car, all the calculations will be done, all the data process will be done, the car itself, because it applies the edge computing devices in the car. So the process will be done there, and you will immediately get the feedback whenever someone cross by. So the car will immediately stop and all that. But if you want to we want to depend on cloud computing, it will take some time. Maybe I already exceeded already. Okay, then only I'm getting the response from the cloud computing saying, hey, no, you have to stop. You already sensed that. Okay, so this is being improved where they introduce edge computing. Edge computing is where we have all these devices. We have these devices, as I said, have to process the data immediately and get the output immediately so that its device can take the next action. So this edge device is introduced to be applied in the network itself. Some devices like smart devices, we have the edge computing, or this is known as edge nodes, whereby everything will be done here itself. Like I want to know how long I walked and so on. But it is lack in battery, it is lack in processing power and so on. So we can't really depend on these devices to process bigger data. So that's why edge computing will be is introduced over here. So edge computing, we have edge servers and all that will be processing all this data and give the output to the device so that it knows how to work and all. It applies in the metaverse world also, whereby as I said, we have to interact in the metaverse world. When I touch something, I have to feel that If I go somewhere, I have to know this is the limitations, so many criteria over there that has to be detected when I'm in the metaverse world. So edge computing is introduced to less the distance between the cloud computing and also the metaverse device user. Then advantage, it decreases the latency, it decreases the bandwidth consumption, but we still have issues in data privacy and security. So to overcome, okay, why, if I go too technical, it will take time. So I'll try to limit my presentation here. Another research work is rather than using edge computing platform, they introduce cloudlets. But if you use cloudlet, it's where it's like a mini cloud in that network, particular network. So most of the data of work, data processing will offload it to the cloudlet. But if we depend on this structure design, all the devices has to be need to have internet connection all the time. If you don't have internet connection, then you won't be able to use that that network. Okay, then so actually I wanted to talk about that for security, but now since I'm talking about technology, I'm technical, I'm leaving this slide. Okay, solution now. We have all these problems that I have mentioned. One is the latency. The other one is the security and all that. So what solution that proposed over here is we introduce the edge servers and also cloudlet in the network itself. Why? Is because, okay, if let's say if just cloud, the edge servers transmitting the data to the centralized cloud, we are still will be sending or transmitting sensitive data to a server that is out of our network. So there are high chances for the hackers to tap and get the data from our network. So instead of depending 100% to the centralized cloud, we have the cloudlet there in the network itself, so that we won't compromise the privacy data and so on. These actually if we go technically, it has a lot of information to share over there. But then if I go deep, then we won't have enough time. Okay, but if you want to know more about this, you can always approach me. I can let you all know what are the algorithms, what are the security system that will be used and all that. Another thing that when we were talking about security, of course, all these edge devices, edge nodes, cloudlet, centralized cloud will have its own security system like antivirus and so on. But then we always need extra layers of security system, because nowadays we know cybercrime is a very huge issue in Malaysia, not only in Malaysia, but around the world. So let's say in the metaverse class itself, okay, let's say I'm a student, but I can be a hacker too. So I might be stealing some data, or I do some crimes there in the metaverse world. So I would suggest that research on the machine learning and artificial intelligence defense algorithm can be done, so that it will be able to detect on any suspicious activities that will be done during the transmissions of data in the cloud, in the metaverse world. That's the second one. So edge computing it's just the introduction about the edge computing. This is the cloudlet. Research area. So now, what are the research that is very popular in this metaverse world? One is about the costing. Very expensive. That is why not many countries are actually trying to implement metaverse technology in their countries. The one that is very interested in this research area is Singapore, and the other two countries I can't remember. So why? Because in order to have this, it's going to cost a lot. Okay, and we expect high-end devices to be used to get the seamless experience and all that. So it is suggested to have some technology that our metaverse platform that can support low-end metaverse devices. Second, about the security, like what I told just now, although we have security through the hardware component and software components, but having a research, doing a research on machine language and artificial intelligence, it will be an added advantage in order to protect the network from cyber crimes and all that. And the last one is the network design. Network design, we can do research on the routing protocols. Okay, we already, because we have 3 layers now. We have devices, we have edge server, and we have cloudlet. Okay, so for the data to be transmitted here and there, okay, it will also consume some time and also will consume bandwidth. So we have to do research on the existing, either on the existing routing protocol, or we enhance the existing routing protocol in order to reduce the transmission between data between these layers. The last one is to an algorithm. Then where are we going to place all these edge computing, okay, or edge servers? That is also very, very important for us to have the seamless transmissions of data. So an algorithm, there are actually a lot of algorithms. You have to do research in order to find which algorithm that can help you to identify the best place to place all these edge devices in the network. So I think that's all for my presentation today. Sorry, yeah, I have to be quick. And if you have any question, you can ask me. My email, room number.
Yes, thank you, Dr. Van. Thank you for the presentation. So we now open for Q&A. Okay.
Okay, so it's very interesting. Know a little bit about the cybercrime attack that you mentioned on the towers.
Cyber.
I think you skipped that slide, right? I was kind of
This one. Like we sorry.
so that is one. And number two is, since you say certain countries are already adopting this metaverse and they have a lot of issues. Yeah. So are there any act or governance policies in usage of metaverse in these countries?
Okay. The first one about the cybercrime. Since we, in order for us to be involved in, to join the metaverse, well, we have to use these devices, VR, AR devices and all that. So when we are using these devices, we are actually transmitting some data from us, like our fingerprints and all that, or to the sensors, the location where we are at and so on, will be transmitted all the time. It will be happening frequently. So when this sensitive data is being transmitted, so we will have hackers over there. We wouldn't know who the hackers. It can be one of our classmates. It can be someone from outside who joined. So so there are a lot of vulnerabilities in the network because our sensitive data is being transmitted so easily if we don't have any defense system. So this data can be easily hacked by these hackers.
Okay, you mean that the devices that are being used right now, okay, these countries and so on, they are not being equipped with any security mechanism?
The countries like metaverse is not, it's just on the research phase in Malaysia, but we didn't apply it.
Maybe the one that you said.
The Singapore, yes, Singapore, like they are one of the top countries that is doing research and also implementing it. But the thing is, I didn't read much about them.
Because I believe that, of course, when you talk about cloud, for example, cloud themselves got their own security services. So if of course there's some protection in terms of that, and the devices you use. I since I have not put this yet, but I believe that probably there is that
even let's say when we are using it at a network, our network, it's at the routers and all that, they already have the defense system. But then it won't be enough because now, although we are improving our security, defense and all that, but we see every day we still have the cybercrime problems and all that. So it's happening because the students or the people are well educated about that, and we have a lot of available tools, free tools to help us to learn about hacking. So that's a layers of security is very important in order to protect.
Any other question from the students? Thank you very much.
Thank you.
Thank you, Dr. Bante.
I think you want to listen to that.
I mean, okay, so may I now invite the last speaker, Dr. Mohammed Amba, who is presenting on the topic Convergence in Action, exploring the intersection of BigQuery, machine learning, and network security overview and demo. Dr. Amba, over to you, sir.
But the link,
That you
this is one, but I don't think so. No, not this one. Okay, just let me. Okay,
Okay.
put one up on that. So.
else.
Really around there. Yes, okay. Okay, yeah, okay.
So again, Assalamu alaikum warahmatullahi wabarakatuh. A very good afternoon, everyone. And today I'm presenting a topic titled Convergence in Action. Let me minimize it. Okay. Exploring the intersection of big query, machine learning, and network security. So we'll give you overview and demo. And yes, there we go. This one is just turning. I don't want this. Can you help me to hide this one? Just see it. Okay. Middle one. Middle. But it's running. Okay. Okay. So sorry for that. So we'll start. I'll start my presentation by giving the outlines for today's talk. So we'll give an overview of a cloud computing platform. Then we'll go give an overview of BigQuery, and then we'll talk about BigQuery ML. Then we'll talk briefly about network security, and the major part will be covered in the network security and BigQuery ML descriptions. And finally, we'll have a simple demo to show you how to use BigQuery ML. So when we talk about BigQuery ML, it's actually machine learning as a service, which is provided by Google Query Platform. And Google BigQuery Platform is a let's say, cloud service provider, and it's over, let's say, a variety of features. So, for example, it's a cloud computing service, meaning that it's provide a range of cloud computing services and network infrastructure, as well as platform services. It's also scalable infrastructures, meaning that it's allowed the user to scale their applications. For example, when dynamically when the changes, or demands. Plus, we have also data analytics and machine learning. And here there are a variety of tools that's provided by GCP, such as BigQuery ML, TensorFlow, and it's allow the users to, let's say, analyze large volume of data using the platform. And also it's a global network and securities, meaning that it has a different data center around the world to ensure low latency when accessing the service of the cloud computing. And finally, it's developer friendly tools. That means over, for example, APIs or versioning controls that allow users to create, manage, and also deploy their application in the cloud computing. And here is the a summary of these services that's available in the cloud computing platform. And our focus in big data, more specifically in BigQuery. So under the big data, we can see a lot of services. But today we will focus on BigQuery and one of its features, BigQuery ML. Okay, so when we talk about machine learning, the ultimate goal is also to allow all the users use, let's say, machine learning. Therefore, in cloud computing platform, there are several tools that's been offered by this platform. So, for example, TensorFlow, and the audience would be data scientists and data engineers. We have ML on BigQuery for data analytics, and we have also pre-trained models for also data scientists and data engineers. And the final one is AutoML, that's allow everyone to use machine learning. So this is the ultimate goal for, let's say, for this, let's say, services and the cloud computing platform. Okay, and when we talk also to talk more specifically about these tools, so there are several tools, as you can see here. So, and these tools are targeting several audience. So if you're talking about TensorFlow and Cloud ML Engine, which is offered by GCP, it's also targeting data scientists, where they can build and deploy, for example, state-of-art custom models, or we can use BigQuery MLs, where you can also build and deploy custom models using SQL, which is a standard SQL query. We can use it to create these models. And the final one is Auto ML, and the audience is developers. And here also we can create also models. So based on our audience, there are services available that this audience can pick up and work on it. Of course, the most advanced one is TensorFlow, and needs specialists in machine learning to use these services. So let's zoom into BigQuery. So I mean, in this talk, we'll briefly talk about the BigQuery. So we have a problem with traditional SQL query. So storing and querying massive data set can be right consuming and expensive if especially use, let's say, wrong or not right hardware infrastructures. So what BigQuery did is allow the users to or to solve this problem by enabling super fast SQL queries using the processing power of Google Cloud infrastructures. So in Google Cloud infrastructures, of course, there is a computing engines, and this also serves not free. It depends on in the model of pay-per-use. So we can help, let's say, to overcome this problem of analyzing large data sets or large data. So when talking about large data sets or large data, we talk about terabytes of data or sometimes zettabytes of the data sets. So this is briefly what is the difference between SQL and BigQuery. So there are differences in terms of many aspects, but the main things like we wanna focus is the language. So here we use structured query language. It's the same in BigQuery, but it's optimized for large scale data processing, meaning that we can use what we have learned in SQL query syntax, and we can use this syntax to write the, let's say, SQL query or Google SQL queries. Of course, there are also other features which allow the users to write SQL, let's say, machine learning using conventional SQL queries. For example, also we have the optimizations when you're talking about SQL query. Here is interaction with the structured data set here is optimized for handling and large scale data sets. Scalability, of course, if we have large use data sets, the best choice is goes to SQL BigQuery. And let's say the last aspect that I want to focus is the server management. So in SQL query is required management of the database server, but when we talk about BigQuery is a serverless infrastructure or architectures. That means the user no need to deploy any services in its machines to use this BigQuery. Okay, so one of the features of BigQuery is BigQuery ML. So what is BigQuery ML? Is basically let you create and run machine learning models by using Google SQL queries. That's mean I can use let's say select statements or create table statements to create a machine learning model, to train it also and use it for the prediction. And there are several supported models in BigQuery ML. Of course, it's not like the well-established let's say tools like TensorFlow, but so far this is the supported model. We can see variety of models. For example, if you're talking about linear regression, if you have a binary classification problem, you can use logistic regressions. In terms of deep learning, also we have deep neural networks. So we can use any of these models to train our data set and use it for the predictions. And if we wanna, let's say, see all the models here, we can access it from this, let's say, link, but I'm not going to show it because we have tight time. But this is the whole models or supported model in BigQuery ML. So of course, this BigQuery is services offered. ML services offered by Google Cloud, so we have to pay for it. But the cost is not, let's say, that's expensive, especially for the, let's say, students or researchers who use, let's say, small to medium database or data sets. As we can see here, that the cost model or the pricing model fall under two main categories. The first one is storage, and another one is the analysis, which is processing queries. So for storage, we pay for gigabyte per month. We pay $0.2 USD, and have a price for long-term storage. That means if I want to save the data set for long term, I get half of this price. First thing, gigabyte per month is free, which is wonderful for the data set, especially from the security background. I can see that most of our database will not exceed the 10 gigabytes, so we can use this service as a free. In terms of the queries that we want to use is $5 per terabytes, and terabytes is 1,000 gigabytes. So it's also, I think, it's suitable for searchers and scholars. First terabyte per month is free, so this is the pricing model for the big query. And for any user who want to sign up in the Google Cloud platform, so it will be given $300 free, so he can explore all of these services. BigQuery and other services exist or offered by Google Cloud platform. Okay, now let's move to the cybersecurity. So cybersecurity is a big topic, and I'm not, let's say, cover it in details, but let's at a glance see what is the cybersecurity. So when we talk about cybersecurity, we always hear about these terminologies. We have information security, cybersecurity, and network security. As we can see, the umbrella for all of these terminologies is information security. And briefly, information security is meaning that you want to secure digital or non-digital data. So digital data is any documents in your laptop, in your PC, on your smartphone. While non-digital information can be a file inside your drawer. So you want to also protect this. Let's say, from unauthorized access by deploying CCTV and other stuff that can ensure the safety of this information. So in a nutshell, information security aims to secure both digital and non-digital information. When it comes to cybersecurity, which is a subset of the information security, its ultimate aim is to protect, let's say, the cyberspace from several types of attacks. And the last one is network security, which is control the access on the network, which consists of networks, let's say software, hardware, and also services. So this is let's say briefly, what is the main terminologies, not concepts, in the cybersecurity. But the problem here, we can see that when we talk about cybersecurity and cybersecurity attacks, we can see that there are a huge number of, let's say, attacks or malwares around the world. So we can see from this figure, in the first half of 2022, we have 2.8 billion malware. Okay, so this huge amount of let's say malwares give us let's say a motivations to propose techniques or mechanism to address this kind of attacks. And also this attacks is compounded with the introduce of emerging technologies. And we can see that some of these attacks already exist in the, let's say, conventional or traditional technology, but the presence of these attacks maybe or the execution of this attack in let's say emerging technology may be slight difference. So for example, if you want to talk about IoT attacks, so IoT attacks, there are two types of this attack. One of them is inherited attacks, and another one is IoT specific attack. So inherited attack, those attacks that exist in the conventional network like IPv4, SDN, or IPv6, let's say network, and it can be executed in IoT infrastructure network. But let's say we talk about the most important thing, the IoT specific attack. And as the name says, it's specific. So it's specific to IoT or targeting all of the IoT. And one of these attacks is both of things. So when we talk about both of things, let's see the destructive consequences of both of things basically depends on the number of compromised ports on the internet. So as you can see here, the number of, let's say, the number of connecting device, IoT connected device, will be 25 billion by 2030. So imagine that portion of these devices got compromised and misused to trigger certain type of attacks. So it will be destructive consequences on the victim network or machines. Okay, so this huge amount of, let's say connecting device also generate a huge amount of data. So by 2040, we have we have 149 zettabytes. Okay, so this is a huge amount of data lead us to the main point of today's talk. How I'm going to, let's say, process this data. So the statistical analysis, let's say rule-based or whatever, is no longer, let's say, able to analyze this data, identify trends, identify patterns inside this data. So for that, we can use BigQuery ML. So BigQuery ML with a network security, the feeder will be the data that is generated from, let's say, IoT connected devices. And usually the data in the context of network security can be collecting from system events, can be collected from network logs, as well from user behaviors. So all the data that's used as a feeder for the BigQuery ML can be used to, let's say, generate or automate anomaly detections, predictive threat modeling, and behavior analysis. So all of these solutions that's based on the ML and BigQuery ML and used to identify the suspicious behavior or abnormal behavior in the networks using the data. So the takeaway from this slide that if we have a huge amount of data, so conventional, let's say, machine learning algorithm will not able to effectively identify the, let's say, pattern inside this data, and this pattern can be used to distinguish between normal and abnormal attacks in the network. Okay, so to recap, so BigQuery ML itself is not specifically or designed for network security. I can use it in different fields as well, because as we can see from the previous slides, our most important things are to have the data. But organization can leverage BigQuery ML for predictive analysis or network security log, anomaly detections, and identifying pattern and active security threats, as we mentioned in the previous slides. So by using ML or leverage the power of BigQuery ML, we can generate this model, and this model can be deployed, for example, online to detect this, let's say, attacks. So when we're talking about any AI-based security solutions, we have, let's say, these solutions, let's say, have four main groups, starting from the data collection and integration. And also we have data processing and feature extractions, followed by machine learning models, deep learning models. We have threat detections and preventions, and we have also adaptive or, let's say, evolving models to capture the changes in the network. And we have also a human oversight and decision making. So in today's, let's say, demo, we'll show you how to generate a threat or detection model using BigQuery ML. Okay, so for the sake of demo, we'll use datasets called IoT intelligent dataset, and here is the record of this dataset. So this dataset consists of 600K or 600 plus K record, and also it has more than 85 features. Okay, so this dataset can be accessible via these links, and I already have. What's the problem? Can't show this one. Okay, so this dataset is already, as you can see here, so it has more than 600K, and it's also have more, let's say, 86 features. So this dataset will be used for the demo, and it can be also we can download this dataset from this link. Okay. So let's start with our demo. We'll use these datasets for, let's say, upload it to the Google Cloud and see how we can process it and how we can generate, let's say, ML model. Okay, to do so, first things we have to have an account on Google Cloud. So you can use your Gmail account and you can sign up. And once you sign up, you will get 300 USD. equivalent to 1,400 plus, and you can use this as a credit. So we can see that we have a lot of services here, and our service fall under BigQuery, and we click on BigQuery Studio. And from here, we can, let's say, open the dashboard for BigQuery. So the first things we want to do is to create a data set. Okay, so we create data set. So we give it a name, for example, demo1, and we click create. Okay, so the demo1 is already created here. Then we click on create table, and the table here, we can populate this table from different sources. It can be CSV file, it can be a text file, or it can be also databases. For me, I'm uploading from from my machines, and I click browse, and I have my data, dataset 1 or data 1, and it's a CSV. So just a quick note here, if you want to upload it from your PC, the size of the file should not exceed 10 MB. So if the file exceeds 10 MB, you can upload the file to the Google Drive, or you can use a service called Basket inside the Google platform, Google Cloud platform. Then we have to name the table. For example, I name it IoT underscore, let's say attack. And the most important thing is to tick these options, auto detect. That means it will generate the same columns, certain columns names in the CSV. It will be created in this table. If we didn't tick these options, we have to create the columns one by one. So we click on the create table. Okay, so it's already here created, so we can click and we can see the columns. Okay, so before that, I already did, let's say, feature engineering and feature selections on the dataset and the cleansing. Though that this also can be done using Google Cloud, BigQuery ML, but this is beyond today's talk. We will focus on how to create the model itself. So as you can see from previous slide, we said that 80 features. I cut off this feature to 10 using, let's say, a feature selection algorithms, and I already have a pre-processing the data. So if we click on the preview, we can have all the data in front of us. And the interesting part is let's see, explore the data. So we open a conventional like SQL query. We can, for example, say count all. And we want to see that, for example, the label class. And here we can also label. And we can run the query. And we can see the distributions of the sets. We have a label class. One is attack, one is normal using SQL query. So it's a balance 25K, 25K. So now let's see if it goes through the process of the ML. First, we want to create or simulate unseen data. That's me when I hold out part of this data and save it in another file. To do so, we have to, let's say, use also again SQL query, all about the SQL query. So we want to use SQL query to manipulate or to deal with let's say with the ML. So to do so, we can use create table. It's normal create table. For example, I name it for example demo1 dot unseen underscore data, and we say that we again select all from again the table that we have created, IoT underscore attacks. Okay, order by run, and this is those who are working in SQL query, they are familiar with this. Limit, for example, I want to hold out 10K record. Okay, so again, this is SQL query. So basically, we create a table called unseen data, and we insert this data on unseen data, and we click run, and we will get the table already created. So after we create this table, we want to remove this data from the original file. So we can also go delete, use the command delete again, delete. from IoT, from this table, we want to delete all the rows that we have inserted in unseen data. So again, where ID in, again, select all, select ID from demo1 dot unseen underscore data. Okay. Okay, so this one, that's mean we want to delete all the IoT attacks with the IT, with the existing ID in this table. So we click run and we prepare our record. So now if we say again, if we run the query, select count all from demo1 IoT attacks, so it will be 40K instead of 40K or 50K. Okay, so it's become 40K. So now we have called out 10K for unseen. So now we come to the interesting part, how we can create a model. Okay, so to create a model, we use also again create model. Okay, and we name this model. For example, demo1 is the name of the project dot sample underscore model, and we give the options. And these options will identify the model underscore type. In my case, it will be logistic regression. And also I will identify the label input underscore label underscore columns. And it will equal to the label column, which is, in my case, is label. Okay. And now we will pass the training data. So the training data, I use the IoT attacks. Okay, so select all from demo 1 IoT attacks. Okay. Okay, if we run this one, it will take a bit time, but let me takes only up to let's say 20K records from the training data. Okay, so we run this one and we wait a bit to generate the model for me. Okay, while it's generating the model, let's back to this query. And if we say that, for example, if we run this query, and if we run this query and we get the results, so Google Cloud will connect you to a different visualization tool. That means you can create your customized dashboard to create these tools. So for example, if we explore here, we have different customization or visualization tools that enable us to visualize all the data. So for example, if I have a look in Looker Studio, so I can do completely customized dashboard, master detail page on to explore all the data. So for example, here I'm loading this. Okay, so here we can, for example, it's automatically, let's say, populating some of the data. For example, if you want to add a bar chart here to represent, for example, let's see the dimension here, we name it to label. And we go here also, we can see that it's automatically, okay, give me the labels, but here we want to change the sum to count. So it will give me the distributions of the, let's say, label class 0, 1, how much I have a class. So if you want to do it, let's say in Excel, I have to copy the data, I have to do a lot of steps. And this is very simple things. There are, you can literally create a master, let's say, dashboard, and it can navigate, and it's, you know, you can create your own control, like for example, drop down list, and you have to your own filtrations, and this filtration, for example, reflected on the table, you can do all of this. Okay, so this is just one of the features that, you know, allow you to visualize the data using Looker. Besides, you can also you explore different let's say visualization tools. And back to our query, we can see that the model has been created. Okay, sample model. Okay, we have created now the model. Now, if we want to go to the, for example, execution or let's say details, or sorry, we can click on sample, and we can also go to evaluations, and we can see all the matrices here, metrics that we use, accuracy of measures. For example, during the evaluations, we have precisions of 98 and so on. So all the stuff that we have been getting using TensorFlow or Keras or sklearn, so all we can get it using SQL query. So now to move to the second part, we want to use how to make use of this table to predict unseen data. So to do so, we can use also built-in function called ml.predict. And this will take two parameters. The first one is model, and the name of the model, as you can see, is demo1.sample model. And the second parameter is where is your, let's see, unseen data or the data that you want to evaluate. So select all from demo1.unseen data. So here I want to evaluate it. So select all. Okay, so we have error here. What is this? It was model. Okay, so let me see the queries that I have created before. Evaluate. Okay, to predict. So this is one of the queries that we use to do predict, but here we say sample underscore model, and here we use unseen data. We remove the limit, and we can run this command. That means here we do predict using the model that we have trained, and we got this interesting results. You see now what is happening. Now I have a class called predicted label 0, and I have a predicted label, let's say, so the probability of this being 1 is 0.06, and the probability of being 0 is 0.9. So that's why it's called 0. So predicted value, predicted label is compared with the actual label, which is 0. So 0 and 0, I mean, the actual label is 0, and predicting 0, that's mean true, positive is true. Okay, 100%. Okay, so now it's, you can see that 10K, let's say 10K records has been evaluated, and we can, let's say, if you want to really see what is the precision, what is the alpha score, we can use another, let's say, another query called, for the sake of time, let me copy paste this also evaluate. Okay, so we can use to evaluate this model, we can use this query, and again we use sample model from demo1, and we can use also from demo1.unseen underscore data, and we can run this command, and we can get the result as you can see here. This is the precision and recall, the accuracy, F1 measure, log load, all these data can be done. And because I don't have time, even these values can be calculated manually using SQL query. Like, for example, I'll show you one of the okay, for example, you can see here what I did, I create my own confusion matrix. You can see here the query is actually responding to confusion matrix. So predicted 1 equal label and label 1 is a true positive. And again, we can count if a predicted label and 0, that's mean true negative. So all of this using standard query, even no need to use evaluate. So what I'm trying to say from this, I mean, try to convey from this demo, literally you can use your SQL skills to work with ML to generate and to predict your SQL, let's say a machine learning using Google BigQuery. Okay, so this is briefly the demo, what I want to show you, show in the demo. And that's all from my side. So if you have any questions, please ask.
Thank you. Come back for the presentation. So we're now open for Q&A.
Thank you, Doctor, for your presentation. So, I have a question. How we can break the threshold by using machine learning techniques? So, actually, I saw you the slide. Threshold and also the analysis.
Yeah. Okay, so the threshold is basically if you go back here and if you go to the, let's say, demo 1 and you go to model and sample, you can see here the threshold is corresponding to ROC curve. And you know that in ROC curves is we have to take several thresholds. So here we can manipulate and see what is the best threshold that corresponding to curve. I mean to ROC curve. Okay, so for example here, if I select 0, the accuracy is really bad. So if I slide it more, so I can enhance the recall and the precision. So from here, for example, you can know that the threshold, this value, give you the best results in terms of, let's say, in terms of recall or precision or fusion.
Is there any machine learning techniques specific for this or can you
So it depends. Okay, so determining is depends. So if you are talking about the threshold, they can be, let's say, dynamic or static. So if we can say static for machine learning, I don't recall that there is a threshold, I mean, machine learning to generate, but there is a statistical methods to generate. Statistical method to generate, like a dynamic threshold. So this is will be slicing the traffic within a time frame, certain time frame, calculate some inputs and give you the threshold that it will fluctuate based on these inputs.
I have a second question.
Just-
What about this like prediction that like the next time, it's like sometimes it's the attack or it's not.
Yes.
Now I'm working about like stages. Okay, stages. So it's been predicting the attack. For example, the attack of this stage is the attack. So next time it's not attack. How is the best?
It depends on how you train your model. So if there's a changes and your model is trained well and solid, it can be the next stage of ABT can be detected. So it's the most important thing is to feed your model with a huge data, and this data must also consider many scenarios. Don't rely on the variety of scenarios. One scenario maybe will not be, let's say, effective, may or detect, let's say, attack in the next stage. Since ABT is many stages, so you have to be careful about the data collection. Welcome.
Any other questions?
Yeah. Actually, so far is whatever is available here. And if you want to really, let's say, read more about it, so you can see this is the list of models that so far is available in the, let's say, Google Cloud Platform under BigQuery ML. And there are also options to split the data using data split methods. But in my presentation, I used the auto methods, which split data based on certain scenarios. And the scenarios are related to the number of rows in the data set. Okay, any questions?
More questions?
There is a request. It's like, can you give whatever your presentations and carry, can it be on the slide?
Time, sure. Yeah, maybe workshop of maybe TensorFlow and mix with this one can be, because this one is limited to certain method, but it's good. I mean, it's really let's say good to use your SQL query writing the model. Something is weird, right? So that's why I try to share with all of you guys. So no problem. As you can see, we predict all using SQL query. There's no need for you to learn Python or learn R to work with ML, especially if your project is small to medium. So don't need to go through all this headache if you have good SQL query. And I think most of undergraduate students already familiar with the database and SQL query. So we can leverage this experience or skills to generate the let's say ML model using these queries. Okay, thank you so much.
Hello, doctor. Hello.
Yes.
Can you hear me?
Yes, I can hear you.
Oh, thank you for the presentation and for the session.
Yeah.
Very mind blowing and a very interesting session.
Thank you.
So, if you don't mind, doctor, I also want to direct my question to Dr. Manet and you.
Yes.
That this session, to have a very good grasp of what this session is all about, I want to kindly suggest, or I want to kindly plead that can we have this like a workshop? Yes, I want to plead with Dr. Manet if we can have this like a workshop, so that we cannot use just this short time, like 44 minutes, to have a grasp of what this BigQuery can actually do for us. BigQuery is imparting our word, and we cannot shy away from the fact that it's also going to help for those that have the machine learning knowledge to expand their horizons as well as possible also. So I want to plead with Dr. Manet to use his good office, and you, doctor, that we can have this as more of a workshop. It will be pleasing to our souls and our mind. Thank you.
Yeah, thank you for your suggestion. I'm willing to give a workshop on this topic. I have no problems. So maybe in the future we can arrange for that. Thank you.
Oh, thank you, Dr. Mohammed, for the presentation. Thank you so much. On behalf of Professor Mohammed, okay. On behalf of Professor Mohammed, I must apologize to our audience. This last presentation was supposed to be a hands-on presentation, but we were not aware, especially from the participants from the ethics track. So as it has been finalized, there may be a workshop on this to put you through. Thank you so much. So we now move to certificate presentation. So may I invite Dr. Nibras for presentation of certificate to our speakers. The first speaker is Mr. Yosef. The second speaker is Dr. Van Tegen. The third speaker is Dr. Mohammed Amba. Thank you so much to our speakers and Dr. Niblas for the certificate presentation. May I now invite Associate Professor Mohammed for announcement and closing remarks.
Okay, first of all, I would like to thank the speakers, Mr. Yusuf, Dr. Waitigi, and Dr. Muhammad to come in and give us the sharing on today's session. So I believe that the request from Victor, we will have to look at it, and it is good. And just announcement, we will be having our research enhanced workshop series for this year by Dr. Tawa. So this is the last series for its end. And this is going to be held on the 12th. So I will make the call later on. And finally, there's another journal club on the 15th by Data to Knowledge track. Okay, so I believe that all the audience here and online, okay, so hang on for a while. I believe that all the audience here would be.
Dr. Lim.
That's okay. That's only that. Yes. For Dr. Lim workshop, she already have enough people. All right. So she said it's okay. So it's only Dr. Tawa and the data to knowledge cluster. Okay, so to the rest, thank you very much. And there is a little snack, so make sure you have it before you leave. And hope to see you again. Thank you.
Please, you can take your food. John.